Good day everyone. In integration part 5, I taught you completing the square method concept and explained the 3 models there. Today we are going to do sums using that completing the square method. But you should know for which type of sums you have to use completing the square method. That is very important, isn't it? So now when the numerator is a constant, that is your integrand should have a numerator and a denominator. The numerator is a constant, just any number or any alphabet which is not the variable of integration, okay? And the denominator is a root quadratic, that is within the root you will have a quadratic, or a quadratic which is not factorizable, okay? Then you have to use completing the square method. Are you clear? So when will you use completing the square method? The integrand should have a numerator as well as a denominator. The numerator should be a constant. The denominator can be a root quadratic or a quadratic not factorizable. Then you have to use completing the square method. Clear? Now, first sum. I is equal to integral dx by 1 plus x minus x squared. Here, the numerator actually it is 1 into dx. So, the numerator is a constant. The denominator is a quadratic which is not factorizable. So, we are going to use completing the square method. Okay. So, now I have taught you completing the square method. Here the coefficient of x squared is minus 1. So, you write 1 plus x minus x squared. First it takes the minus out. So, you will get x squared minus x minus 1. Okay. What is the coefficient of x now? Minus 1. Divide it by 2. You will get minus 1 by 2. Square it. You will get 1 by 4. So now put this, write the expression as it is, plus 1 by 4 minus 1 by 4. Okay. So now recollect what you learned in the last video. Now the minus, let it be there. Take the x square term, x term and the positive square you have added. The square root of this is x. The square root of that is 1 by 2. There is a minus here. So whole square. Now you are having minus 1 and minus 1 by 4. If you take LCM, you will be getting minus 5 by 4, which you can write as minus root 5 by 2 the whole squared. Then close the bracket. Now I have told you in the last step we have to bring back the minus inside. So now you will get root 5 by 2 the whole squared minus x minus 1 by 2 the whole square. So the given expression we have now made it as completing the square method. Okay, we have used that method now. Now let us come to I. So now I can write this as integral dx by, now I will write this root 5 by 2 the whole square minus x minus 1 by 2 the whole square. What format it is? Dx by a squared minus x squared. You know the formula is 1 by 2a log mod a plus x by a minus x. Okay. So now a is root 5 by 2 and x is x minus 1 by 2. So now 1 by 2a, 1 by 2 into a log mod a plus x, that is x minus 1 by 2 by a minus x. Okay, plus c. This 2 and this 2 will go. I will get 1 by root 5. You can take 2 as the LCM for the numerator. You can take 2 as the LCM for the denominator. That 2 will get cut. So you will get here log mod root 5 plus 2x minus 1 by root 5 minus 2x plus 1 plus c. Do you understand? So it is just using the completing the square method, the denominator you are converting, then it will be either one of the 6 formulae you have already learnt. So use that formula and then you write the result, simplify it. Is this sum clear to you? Anyway, let me do you one more sum now. The second sum, I is equal to integral 1 by root of 2x squared plus 3x minus 2 dx. Now it is a root quadratic. If the quadratic is within root, no need to check whether it is factorizable or not. If it is a root quadratic, then the only method is completing the square method. Okay? If it is just a quadratic, you have to check whether it is factorizable or not. Now, let us take whatever be the quadratic inside. That is 2x squared plus 3x minus 2. Now you have a coefficient 2 before that x squared. So first what you have to do? Take that 2 out. You will get x squared plus 3 by 2x minus 2 by 2 will be 1. Right? Now the coefficient of x is 3 by 2. You divide it by 2, that will become 3 by 4. Okay? Square it. You will get 9 by 16. So, 2 into x squared plus 3 by 2x minus 1 plus 9 by 16 minus 9 by 16. Okay, do you understand? I have divided the coefficient by 2, then I have squared, I have added and subtracted. Now, you know you have to take this term and this one, right? 2. The coefficient, the root of this is x, that is 3 by 4, this is plus. So, x plus 3 by 4, the whole square. Now, you have minus 1 and minus 9 by 16. Okay? If you take LCM, you will be getting minus 25 by 16. So, minus sign, I will be getting 5 by 4 the whole square. Okay? So, we have done that completing the square method here. Now, let us come here. That is equal to integral 1 by, put a root. Now, this 2 is also within the root. So, I can write outside 1 by root 2. Do you follow? This 2 and this whole thing is within root. So, this number part, I am taking outside the integral as 1 by root 2. So, within root I will now have x plus 3 by 4 the whole square minus 5 by 4 the whole square dx. This is what format it is? Integral dx by root of x squared minus a square. Okay? For that, you know the formula is log mod x plus root of x squared minus a square plus c. So, using that, you first write this 1 by root 2 as it is. Then log mod. In the place of x, you write x plus 3 by 4, right? Then plus root of this one, no? X squared minus a squared. Actually, you come to the working part. This is the thing you are going to write. That is equal to this, that is equal to that. So, I can write that step. You can write this, there is no harm in it, but it is better. Actually, this and previous step like this. So, now actually I can write here x squared plus 3 by 2x minus 1 plus c. So, straight formula log mod x plus root of x squared minus a squared, and I have written it in the simplified form. That's all. So, actually this type is very easy because your numerator is just having a constant. The denominator is going to be either a quadratic or a root quadratic. You are going to use completing the square method. Straight away use the formula. That's all. Okay, is it clear? Shall we move further? Now we are going to see another new concept, a very important one. Okay. When the numerator is a linear. What is a linear? Either it will be just some x term, that is 2x, 3x like that, or an x plus or minus a constant, that is called a linear. Okay, first degree. So the numerator should be a linear. Then the rest is same. The denominator can be a root quadratic or a quadratic not factorizable. So, in the last concept, numerator constant, here numerator linear. That is the only difference. Okay. Now, what is the concept we are going to use? You will write the numerator is equal to some a. A is some constant, okay? A into d by dx of the quadratic, not the root, okay? No root. D by dx of the quadratic plus b. Here a and b are constants. We will be finding the values. I will teach you how you have to do it. But the concept, this is the one, remember. So, both the concepts you should remember very clearly. The numerator is a linear, the denominator is a root quadratic or a quadratic not factorizable. Write the numerator is equal to a into d by dx of the quadratic plus b. Okay. Now, let us go for the example sum. I is equal to integral 5x minus 2 by 1 plus 2x plus 3x squared dx. Now the numerator is a linear, the denominator is a quadratic not factorizable. Okay. So now the numerator, what is the numerator? 5x minus 2. That I will write as a into d by dx of. I will write the quadratic properly. That is, first I will write the x squared term, then x term, then constant term. Okay. So 3x squared plus 2x plus 1 plus some other constant b. Okay. Now that will be equal to a into, if you differentiate you will get 6x plus 2 plus b. Here you have 5x minus 2. Now I am going to equate the coefficient of x on both the LHS and RHS, and I am going to equate the constant terms. Do you follow? So, here the coefficient of x is 5. That will be equal to, here the coefficient of x will be 6a. Okay. So, I will get a is equal to 5 by 6. Actually, in this type of sums, you will get some fractions. You need not bother about it. Then, I will now equate the constant terms. The left hand side, the constant is minus 2. The right hand side, I will get 2a plus b. Do you follow? 2a is a constant plus b. Now, a I know it is 5 by 6. So, 2 into 5 by 6 will give me 5 by 3 plus b. So, my b will be minus 2 minus 5 by 3. If I take 3 as the LCM, you will get 3 2s are 6, 6 and then 1 5. So, b will be equal to minus 11 by 3. So, a is 5 by 6 and b is minus 11 by 3. Do you understand how to find the values of a and b clearly? Okay. Now, I can write the numerator, that is that 5x minus 2 is equal to a into, that is 5 by 6, okay, into the d by dx is what? 6x plus 2 plus b is minus 11 by 3. So, the numerator can be returned like that. You will understand in the next step what is the benefit we are getting because we are writing like this. Here, don't take anything common out here and cut. I want that d by dx of the denominator as it is. Never take anything common, never cut anything. Okay. So, now This is our numerator. So now we can write our I as I is equal to, instead of the numerator, now I am going to write 5 by 6 into 6x plus 2 minus 11 by 3. I will write the denominator as it is in the proper format. Okay, dx. Do you follow? So now we have returned the numerator. What we have here done using that concept, and I am writing the denominator as it is. Now we are going to split this into two integrals. The first part, I will take 5 by 6 out and I will write 6x plus 2 by 3x squared plus 2x plus 1 dx. Second part minus, I will take 11 by 3 out. I will get 1 by 3x squared plus 2x plus 1 dx. Now I can write my I is equal to 5 by 6 I1 minus 11 by 3 I2, and this step I will call as 1. Do you follow up to this? First, use the concept. You have evaluated A and B. Then the numerator you have written using that A and B. And the I, now you are splitting into two integrals and we are writing this. Okay. Now, if you look at your I1, you know it is a very simple sum of substitution, because you know the numerator is actually the differential of the denominator. So, if you substitute the denominator as t, the numerator is straight away going to be dt and the answer will be log of the denominator straight away. In all sums of this particular type where you use this concept, the first part of the integral will be substitution and the answer will be log of the denominator. Okay. Coming to the second part, it is a constant. That is, the numerator is a constant. The denominator is a quadratic. So, you know it is completing the square method. So, here it is a combination of two concepts. One is substitution and one is completing the square method. So, this sum is actually a bit lengthy, right? Because first you are using this concept, then here substitution, here completing the square method. Okay. So now let us do I1. Now I1 is equal to integral 6x plus 2 by 3x squared plus 2x plus 1 dx. If it is in the objective type, no need of working. You can straight away write it is log mod 3x squared plus 2x plus 1. But anyway, now if it is a subjective, then let me teach you the steps what you have to write. So now I will write 3x squared plus 2x plus 1, that is equal to t. When I differentiate, I will get 6x plus 2, that is equal to dt by dx, which gives me 6x plus 2 dx is equal to dt. So the I1 now becomes integral dt by t, which is log mod t plus c1. Because you are having two integrals, I have already told you, write them as c1, c2, finally merge it. So now here t I will substitute. So I will get log mod 3x squared plus 2x plus 1 plus c1, mark it as 2. This is your I1. Okay. So are you clear till this I1? Now let us move for I2 now. Now I2 is integral 1 by 3x squared plus 2x plus 1 dx. Already I told you the numerator is a constant, the denominator is a quadratic, not factorizable. Use completing the square method. So now you take the 3 out, you will get x squared plus 2 by 3x plus 1 by 3. Okay. So 2 by 3, if you divide by 2, you will get 1 by 3. If you square it, you will get 1 by 9. So you will get 3 into x squared plus 2 by 3x plus 1 by 3 plus 1 by 9 minus 1 by 9. Take this term and this. So you will be getting x plus 1 by 3 the whole square, right? Then you have 1 by 3 minus 1 by 9. 9 is the LCM here. So here you will get 3 and here you will get minus 1. So it will be 2 by 9. So you will write root 2 by 3 the whole square. Okay, I think by now you should be clear about the completing the square method, how to work out. So here I will get integral 1 by, this 1 by 3 I will take out. I am getting x plus 1 by 3 the whole square plus root 2 by 3 the whole square dx. This is like integral 1 by x squared plus a square dx. You know the formula, it is 1 by a tan inverse x by a. Okay, so now I will get 1 by 3, this 1 by 3, a is root 2 by 3, so 1 by root 2 by 3 tan inverse x, that is x plus 1 by 3. I think I will put a bracket here. This is the working, x plus 1 by 3 by root 2 by 3 plus c. Here this 3 and this 3 will go, so I will get 1 by root 2. Okay, then here if I take 3 as LCM, I will get here 3x plus 1 by root 2. This 3 and that 3 will go, plus c. This is my I2, C2, sorry, C2 you write, and this you put as step 3. Now we have to substitute C2, 3 and 2 in your 1, isn't it? You have done like this already. So now you substitute 3 and 2 in 1. So now I will get I is equal to 5 by 6 I1, that is log mod 3x square plus 2x plus 1. Don't write that C1. Then coming to minus 11 by 3. Here there is one root 2 tan inverse 3x plus 1 by root 2. Okay. Plus you can write a C, which will include the C1 as well as C2. So actually it is a bit of lengthy sum, but if you understand the procedure how to do, it is easy only. That is, first what you do, the numerator is a linear, that you are writing it as a into d by dx of the quadratic plus b. By equating the coefficient of x and the constant terms, you are finding the values of a and b. You put it in your I. Then you are splitting it into two integrals. The first integral I told you, it is substitution. The second one is completing the square method. Then you can substitute the results in your I. Is it clear to you? Today I have taught you two different concepts, isn't it? That is, when the numerator is a constant and the denominator is a root quadratic or a quadratic not factorizable, we have to use completing the square method. The second concept I taught you is, when the numerator is a linear and the denominator is a root quadratic or a quadratic not factorizable, use numerator is equal to a into d by dx of the quadratic plus b, and then how to proceed. Okay. Now one more step up we are going. Okay, one grade further. Now, if you look at the two sums I have given here, you are having I is equal to integral e power x by root 5 minus 4 e power x minus e power 2x. And here some sin theta, cos square theta, etc. So, straight away, they are not any quadratic or they don't belong to this model, isn't it? But you have to substitute. After the substitution, these sums will come to any one of the two concepts today I taught you. I am not going to do the sum fully. I will tell you the hint up to the step where you get the previous model. Then you please work it out and complete the sum. Okay? So now, see this sum. You are having an e power x here, 1 e power x, e power 2x. You know e power 2x is nothing but e power x the whole squared. So here what I am going to do is put e power x is equal to t. This is the substitution I am going to make. Okay. That is a bit easier because when you see the terms you can easily find it out. When e power x is t, Even when you differentiate, you will get the same e power x, that is dt by dx. So I will get e power x dx is equal to dt. So the I is going to now become that numerator I will write dt. The denominator is 5 minus 4t minus t squared. Just look at this step now. Now this is the numerator is a constant 1. The denominator is a quadratic in t. That is, it is a root quadratic. Okay. So you have to use completing the square method and do the integration with t as the variable of integration. Finish the sum. In the final step, for t, you write e power x. That's all. So like this you have to think. You have to go from one step like that, you should understand. So this is comparatively easier. Now let us come to this sum. This looks a bit confusing, isn't it? So first what I will do is, let me write 2 into sin 2 theta is 2 sin theta cos theta minus cos theta by, I am having here sin theta. So if I have sin squared theta only, it will be easy for me to substitute. So that cos squared theta I will write 1 minus sin squared theta minus 4 sin theta d theta. This is the first step. Then in the numerator, this cos theta is common. So I will write cos theta into 4 sin theta minus 1. The denominator, let me write properly. First I want to write sin squared theta. Okay. Then I want to write minus 4 sin theta. Then I am having a 6, I am having a minus 1. So I will get plus 5 d theta. I think now you will get some idea, isn't it? Because the denominator looks like a quadratic in sin theta. And if you differentiate sin theta, you are going to get cos theta, correct? So now you are going to put sin theta is equal to t. Okay. When you differentiate, you will get cos theta is equal to d theta. Cos theta is equal to dt by d theta, because I am differentiating with respect to theta now. Bring the d theta here. So cos theta d theta will be equal to dt. So the I will now become, this part is going to become dt. This will become 4t minus 1. Here you will get t square minus 4t plus 5. Then this cos theta d theta I will write dt. Now look at this sum. How does it look like? The numerator is a linear and the denominator is a quadratic, not factorizable. So it comes to the second concept, you remember? Now treat this as your sum now. So here write the numerator as a into, don't write d by dx, you write d by dt, okay, because t is the variable here. D by dt of the quadratic, that is this t square minus 4t plus c, 5 plus b, evaluate a and b, get two integrals, first part substitution, second part completing the square method. After finishing all the process, wherever t is there, substitute sin theta. Actually, this is a good sum. If you do this, you will be understanding many concepts clearly. So, all of you, after watching this video, do these two sums yourself so that you will be clear about both the concepts and how to go about the sums. Okay? So, next video we will see some other new concept. Thanks for watching the video. Share it with your friends and classmates. Thank you once again.